Hello friends, I welcome you to my YouTube channel MacPM. So in this video we will study about columns. So first of all, in this video we will see what is the column and what are the type of failures of the column, and then in next few videos we will derive the Euler formula, and we will study about the various end conditions of the column. Then we will study some numerical problem. We will solve some numerical problems in upcoming videos. So please follow this playlist for more. Okay, so first of all, let's see what is the column. So a machine part subjected to an axial compressive force is called a strut. Okay, and a strut may be horizontal, inclined, or even vertical, but a vertical strut is known as the column or pillar. Okay, so anything which can be subjected to axial loading is called a strut. Okay, it can be like this, it can be perfectly horizontal. Okay, it can be compressive or tensile load, but if a strut is perfectly vertical, okay, then if axial load is applied on this strut, then it's called a column, and it can also be called a pillar. Okay, so this is column. Column is always vertical, as we have studied about beams. So in case of beams, mostly load support was like this, or it may be cantilever, and load was applied vertical, transferred to this section, okay, perpendicular to this section. But in case of columns, usually load is axial load. Okay, usually load is applied like this, not like this. Okay, so I hope you understood what is the difference between column, strut, and beam. Now, so what are the type of failures of the column? So column can fail in three ways. Okay, first is direct compressive stress, second is buckling stresses, and third one is combined direct compressive and buckling stresses. So these two are the different methods, and third one is combination of these two. So what is direct compressive stress failure? Suppose there are two columns. This is column number 1, this is column number 2. Okay, so in this case, suppose this is fixed here, then if we apply vertical compressive load here on this column, then what will happen? It is very small, its length is very small. Okay, length is comparable to width. Okay, so in this case what will happen, that this column will fail due to crushing. Okay, suppose sigma c is the crushing stress. So what will be the stress developed in this piece of the column? It will be sigma is equal to P by A, because simply we know that stress is force divided by area. Okay, so suppose this is P. So what will be the crushing stress? Maximum crushing stress is equal to crushing load upon area of this column. Okay, this is for a small column, but suppose this column is very big and then load P is applied here, then what will happen? And suppose this is fixed here or pinned here. So in this case what will happen, that instead of failing due to crushing, this column will try to bend like this, it will change shape like this. So this is called the buckling of the columns. Okay, so this is called buckling. So if there is a long column, practically we encounter many long columns in beams, in supports. So in case of long columns, they mainly fail due to buckling, not due to crushing. Crushing load is important only in a small column, but its column is having considerable length, then buckling load is failure due to buckling is more. Okay, so suppose this is a column initially, and after bending or after buckling, it changes shape like this, and this is E, this is eccentricity, or this E is maximum bending of the column at center. Okay, then we have studied in case of beams that M upon I is equal to sigma upon y. So in this case what will be stress? So sigma is equal to M y upon I, and I upon y is called z, okay, section modulus. So sigma will become m upon z. So but in this case, what is the moment? Moment is equal to force into distance, so it will become m is equal to pe. So sigma buckling will be equal to pe upon z, okay. So this is stress due to buckling, and there was one more stress, crushing stress. Sigma c was equal to pc upon a. So there are two stresses, okay. So if load is applied on the column, then these two loads will act at same time, okay. So maximum load, maximum stress sigma max will be equal to sum of these two when they will act in same direction, pz pe upon z plus pc upon a, and sigma minimum will be when they are in opposite direction, so it will be pc upon a minus pe upon z. And these two stresses, one is direct stress, one is stress due to buckling. So which one is more important will depend on the length of the column. If column is not very short, then major stress will be due to buckling. This one will be more important. But if column is very small, then this will become significant too. So in next videos we will see the Euler's formula, okay. So we will see Euler's formula, and we will derive Euler's formula for one case, okay. So I hope you understood up to here what is column and what are the type of failure of the column, okay. Thank you for watching this video.